today we're going to go over the chain rule for derivatives. So if y equals f of g of x, then y prime equals the derivative with respect to x of f of g of x is equal to f prime of g of x times g prime of x. So this means that if y is a composite function, f of g of x, then the derivative of y is the derivative of f evaluated at g of x, then multiplied by the derivative of g at x. Sometimes this is also written as if we have y equals f of u, then y prime is f prime at u times u prime. Sometimes that notation it looks a little strange to start with, but sometimes that's a little easier as we go. So it can be very useful to be able to identify the inner function and the outer function of a composite function. So the first thing that I'd like you to do, I'm going to go through example A, and then I'd like you to work through A through E on your own. So what we're looking to do here is we're looking to define u as our inner function. So I'm hoping you can see here that u would be 3x plus 1. And then our f of u would be u squared. Okay, so you can see that our final function over here, 3x plus 1 squared, is something squared, and that something is 3x plus 1. So pause the video now and try B through E. Okay, I'll give you a couple seconds to check your work. If you need to pause the video, do that. I think if people are going to have problems with this, it's usually on D and E. Okay, people can usually identify u, and then for whatever reason they have a hard time coming to 1 over u. And just remember 1 over u is defined as u to the negative 1, so either of these would be fine. Then this is something you want to get comfortable with. Here, our inner function was actually the tangent of x, and so we squared that. Okay, so that was our outer function. So for example 1, I'm hoping that you get to the point that you can do some of this as mental math. But to start with, I think it's useful to write out the inner function and the outer function, the same as we did in the table built above. So the first thing that I'm going to do is I'm going to define u. So I want to think, what is my u? What is my inner function? And here it is x squared plus 1. So then my f of u is u cubed. So next, I need to use the chain rule, which is going to tell me that y prime is f prime of u times u prime. So now I need u prime and I need f prime of u. So u prime is 2x and f prime of u is 3u squared. So I'm just using the power rule in both of those cases. So now my y prime is f prime of u, which is 3u squared, times my u prime. So when I write this out, my 3u was x squared plus 1, and we're going to square that, times u prime was 2x. So for the chain rule, for the most of the time, we are just going to leave this in factored form. So 3 times 2x is going to give us 6x times x squared plus 1 squared. You do not need to spend the time to expand this out. Just going to clean it up a little by adding my y prime. Put this here. would be my final answer. Okay, so that's my slope at any point along my original function y equals x squared plus 1 cubed. Okay, let's move on to our next example. Okay, so what I would like you to start with is see if you can find u, f of u prime, and f prime. Pause the video and try now. Okay, so my inner function, which was what was in parentheses, 3x minus 2x squared, the derivative of that is 3 minus 4x. My outside function was the same as in example 1. It was u cubed, so my derivative was 3u squared. So we're going to use that our derivative is the derivative of f, so 3u squared times the derivative of u prime. So now plugging this in, we have 3 times u squared is 3x minus 2x squared times 3 minus 4x. You could leave it like this. A lot of times you're going to see they'll multiply this. So 9 minus 12x times 3 minus 2x squared. And I just realized that I forgot a square in here, right? This should have been 3u squared. Okay, so I had in my head gone back and thought, do I have all of this? Do I have 3 something squared, something prime? I think we've talked about this a little in class, about how there's a lot of room for arithmetic mistakes. I am actually okay with you leaving it at this step. Okay, for example 3, I would like you to pause the video and determine u prime, f of u, and f prime of u. So I apologize, I had a typo on my paper. I'll update it on yours. So hopefully you see that our u is x squared minus 1, so u prime is 2x. So then our f of u is the cube root of x. I think it's useful to always rewrite these with an exponent, so x to the 1/3. So then our f prime of u is 1/3 x to the negative 2/3. So again, our y prime is going to be f prime of u times u prime. So substituting in, that's 1/3. This also should be a u. I apologize for that. So 1/3 of u was x squared minus 1 to the negative 2/3 times u prime was 2x. So this shows me how you do it. Generally, we want to make sure we don't have negative exponents. So I would be rewriting this as 1 times 2x would give me 2x. Then in the denominator, I had to have 3, and then something to the 2/3 power is a cube root of that expression squared. Okay, so as I'm writing my y primes in, I'm also just making sure I have my derivative correctly. Looks like I copied everything in correctly, and then 2x times 1 is 2x. The 3 comes into the bottom. This is my index, this is my exponent in here. So that would be my derivative. Okay, moving on to example 4. So what I would like you to do here is determine u, u prime, f of u, and f prime of u. Okay, so here my u was 2t minus 3, my u prime was 2, my f of u was negative 7 over u squared. I rewrote that as negative 7 u to the negative 2. So finding the derivative of that, negative 2 times negative 7 was 14. I lowered the exponent by 1. I can also rewrite that as 14 over u cubed. So now my y prime is f prime of u times u prime, which is 14 over my u cubed, so 2t minus 3 cubed times my u prime, which is 2. And so when I simplify, the 14 times 2 is 28 over 2t minus 3 cubed. So for our last example, I'd like you to find u, u prime, f of u, and f prime of u. So here, u was cosine x, so the derivative is negative sine of x. F of u was that function squared, so f prime of u is 2u. So again, our y prime is f prime of u times u prime, which is 2 times our u, which is cosine of x, times our u prime, which is negative sine of x. Remember, those parentheses again are important. If you put just the minus sine of x, it would look like subtraction when what you're really doing is multiplying. So then I'm just going to rewrite this as negative 2 cosine x sine x. As always, if you have any questions, please ask.